Given that w is a complex number, prove that w multiplied by w complex conjugate is equal to the modulus of w squared. Let's consider a complex number w and let it be represented in the Euler's form. You may consider it to be represented in the Cartesian form. It doesn't matter. So let w be r multiplied by e to the power y theta. Hence w complex conjugate becomes r multiplied by e to negative y theta. So w multiplied by w complex conjugate becomes r squared e to I theta multiplied by e to negative I theta. So it's r squared, and it's what? It's the modulus of w squared as required. Then two complex numbers z and w satisfy the following equations. Given that modulus of w is equal to 2 root 5, find z, expressing your answer in the form a plus bi, where a, b are integers. So it is given a system of two equations or simultaneous equations, and since a modulus of w is given, and from the previous we can see that this modulus can arise if such product w and w complex conjugate arises, and since it's a system of two equations, we can do the same operations on both sides. So we can multiply both sides, the left hand side and the right hand side, to get w multiplied by w complex conjugate. So it becomes 5z w multiplied by w complex conjugate is 10 plus 10i multiplied by 1 minus 2i z squared. And using that w complex conjugate is equal to the modulus of w squared, so it's 2 root 5 squared so we get, and we can divide both sides by z to get 5, and it's what? It's 4 times 5 is, we can factor out 10 here, 10 1 plus I multiplied by 1 minus 2i and multiplied by z, and it becomes 10. We can divide by both sides by 10 and expand this to get z multiplied by 1 plus I minus 2i and minus 2i squared, so it's plus 2, and hence z becomes 10 over 3 minus I. And to get the required form, we can just multiply numerator and denominator by 3 plus I to get a minus b times a plus b, which is just a squared minus b squared, and it becomes 9 minus I squared, so it's 9 plus 1, it's 10 3 plus I, so finally it's 3 plus I. And that's all for this question.